Have you heard about stars that detonate like clockwork yet don't pass on? We are going to observe a novel space blast that is apparent from everywhere. Unlike a cosmic explosion in which stars catch fire completely in an enormous light show, an old star can also produce so-called nova blasts. The exhibition is also worth seeing, and we don't simply see it once, but again and again. A nova in the Corona Borealis system is going to detonate, and we are eager to see it. Many individuals long for seeing a nova with the unaided eye from Earth. Novas are enormous nuclear blasts that light up stars multiple times brighter for a brief time. We will most likely consider the impending nova to be one of the brightest points of light in the night sky for quite some time. This is incredible news for space fans. This galactic treat truly doesn't show up every day. T Corona Borealis detonates about every 80 years, most recently in 1946, and now it's about to reoccur. This divine blast promises to be one of the brightest and most striking heavenly events of the decade. A nova happens when two stars in a binary system interact with each other in an unusual way, releasing a gigantic amount of energy. This then prompts a blast and an unexpected increase in brightness so that a new star appears in the sky. Novas are not just interesting to observe but also deeply fascinating from a scientific perspective. It's sometimes unimaginable what occurs in our universe, and anyone who knows the true background of a nova will be astounded. Is a nova actually a star birth? You probably all know that the origin of the term nova comes from Latin and means new. Tycho Brahe, the famous 16th century Danish astronomer, coined the term when he unexpectedly noticed an exceptionally bright new star in the night sky. He called this phenomenon stella nova, or new star, later shortened to nova. For him, with the technical possibilities of the time, it really looked as though a new star had been born. However, what the astronomers had seen at the time was not the birth of a star but a violent eruption with a subsequent nuclear blast in an existing star system. A nova is really a maybe short, but incredibly bright flash of a white dwarf star. White dwarfs are formed when stars the size of our sun have spent their fuel supplies. Instead of detonating, they lose a lot of their size and shrink. White dwarfs which exist in binary systems can then have the property of sucking matter from their companion star. When a critical amount is reached, the blast occurs, which we can then see as a nova. The difference between a nova and a supernova is straightforward. The nova is formed in a binary system where a white dwarf gathers matter from a companion star. The white dwarf is not annihilated by the blast. It can indeed produce several novas over millennia. Supernovae are much rarer events in which a star is completely destroyed by the blast. Type Ia supernovae are extraordinary phenomena similar to simple novas. Once again, a white dwarf is involved. However, in this case, the white dwarf accumulates so much matter that it no longer survives this final blast and disintegrates. The brightest supernova brightnesses are those of type 2, in which a massive star with at least 8 solar masses collapses at the end of its life. The brightness of a nova is impressive, but it is much fainter than that of a supernova. What we will soon see is a simple nova of a small white dwarf, which will not die in the process but will give us an incredible light show. When the time comes, the white dwarf will show an unexpected increase in brightness of more than 1,000 times. Such events are usually only visible with telescopes, but in this case, the nova is so close that we can see it with our own eyes. The brightness of a nova and a supernova that we can see from Earth generally depends on how far away they are. A nearby nova can appear brighter to us than a very distant supernova. The next supernova visible from Earth will be the blast of the star Betelgeuse. Scientists do not yet know exactly when this will be. Perhaps tomorrow, perhaps not for a few thousand years. However, we will certainly see the nova of the white dwarf T Corona Borealis, and the next one will almost certainly come in 80 years. Despite being 3,000 light-years away, it will be visibly apparent. It's truly amazing. T Corona Borealis is more than 3,000 light-years away from us, and yet we will be able to see it very well with the unaided eye. The binary system is located in the constellation Corona Borealis. This white dwarf is a very dense, compact remnant of a former sun-like star. After the original star had spent its nuclear fuel, its core collapsed, the outer layers were ejected, and a white dwarf remained. The companion star from which the white dwarf is extracting material is a red giant. This star is also approaching the end of its life and has begun to expand. These outer layers are gradually drawn to the white dwarf and accumulate until the conditions are right for a nuclear blast. This blast will then significantly increase the brightness of the white dwarf and give us a nova. According to predictions, the nova will reach a brightness of around 2.5 magnitude. This means that the apparent new star will then be one of the brightest objects in the night sky for a few days or even weeks. Even if you live in the city and in places with light pollution, you will be able to see the bright spot in the night sky with the unaided eye. The constellation Corona Borealis is also referred to as the Northern Crown. On some German star charts, you can easily find the constellation because its semicircle shape makes it very easy to recognize in the northern sky. It lies between the two fairly better-known constellations of Boötes and Hercules. If you look between the two, you'll see some very bright stars forming an arc. This is the Corona Borealis. The brightest star at the top of the arc is Alphecca, sometimes referred to as Gemma. From Alphecca, you can easily trace the other stars of the arc and easily recognize the entire constellation of the Northern Crown. It's best to look that way now and remember the star constellation. After the blast, a very bright new star will be visible there. This is the nova. The best time to see the nova will be late in the evening when Corona Borealis is high in the sky. A nuclear disaster every 80 years? It's crazy. We're enjoying a phenomenal glow on Earth, and a fiery blaze is actually taking place 3,000 light-years away. The looming nova in the T Coronae Borealis system is an event that happens in a specific sequence like clockwork. The first known eruption of T Coronae Borealis was seen in 1866. During this time, a bright star suddenly appeared in the night sky, which was seen and recorded by many astronomers at the time. This phenomenon was repeated in 1946, exactly 80 years after the first observation. The 1946 eruption was studied in much more significant detail by astronomers worldwide. Further historical reports by an abbot named Burchard von Herber from the year 1270 show that the nova has been a companion of humankind for quite a while. Herber noticed an unusual lighting up in the region of Corona Borealis. Recently, astronomers have noticed increased activity in the T Coronae Borealis system. Since 2015 and 2016, there have been repeated unusual variations in brightness and a dramatic increase in radio and X-ray emissions, both obvious signs of an upcoming eruption. The observations are very similar to the activity documented by astronomers during the previous eruptions in 1866 and 1946. As early as 2018 and 2023, there were remarkable changes in brightness that caused scientists to sit up and take notice. They compared their data with the data from 1946 and found surprising similarities. These recurring signs very likely indicate that the next nova will happen in September 2024. Then we might see a light that is one of the brightest in the night sky for a few weeks. This white dwarf will most likely produce many more novas after this blast. It may take millennia before it collapses completely or triggers a Type Ia supernova. We don't know the exact number of potential novas. We have not been observing the phenomenon long enough for that. Researchers have determined in simulations that the amount and periodicity of novas depend on several factors, including how much accumulated matter and the efficiency of the accretion process. It's the spins of the two stars and the gravitational forces that the two have on each other. In a periodic nova system, like T Coronae Borealis, the white dwarf continuously attracts material from its companion star, a red giant. This matter then forms an accretion disk. The mass gradually reaches the surface of the white dwarf. Now, of course, the question arises, why does the accreted material then explode? The accumulated matter on the surface of the white dwarf consists primarily of hydrogen. When the mass of this hydrogen layer reaches a critical density, nuclear reactions begin. The reactions release enormous amounts of energy, similar to a giant hydrogen bomb. When it goes off, there is a sudden explosive brightening, and the nova becomes visible. We are looking forward to many more novas. Systems with white dwarfs and red giants are such extreme places that they are certainly not inhabited, so we can continue to enjoy the beauty of novas. While everyone's eyes are currently on T Coronae Borealis, we can announce that there will soon be more novas in other star systems. Another periodic nova system is RS Ophiuchi, which consists of a white dwarf and a red giant.